Hello, welcome. Let us today discuss about the trinomials, the factorization of trinomials. Okay, first to define a trinomial. A trinomial is a polynomial with three terms. Today's learning objective is factoring trinomials with a leading coefficient 1 and factoring trinomials with a common factor and factoring trinomials with a leading coefficient other than 1. Okay, the general form of a trinomial is ax squared plus bx plus c. If a is equal to 1, it becomes this form. Okay, let us first discuss about the factorization of trinomials of x squared plus bx plus c. Then we will come to the more complicated case when n not equal to 1. Okay, before factoring, let us review some properties of multiplication of two binomials, because a trinomial, if a trinomial can be factored, then it can be represented as a product of two binomials. Okay, so let's review that first. For example, x plus 3 multiplied by x plus 7, these two binomials. Let's multiply these two binomials by using the FOIL method. A FOIL method is a method to multiply two binomials. The idea is first to multiply the first terms of the two binomials. The first terms of the two binomials is x and x. And the second is multiply the outer terms of these two binomials. So if you consider these two binomials, the four terms, the outer term is this x first, and the second outer term is the 7. And multiply these two together. And third one, the inner terms, the product of the inner terms. The inner terms are, again, if you consider the four terms, the inner terms here is the 3 and the x, and multiply together with the 3 and the x. And finally, the product of the last terms of the two binomials. So here, the last two terms are 3 and 7. Okay, let's multiply the first two terms of the binomials, x and x is x times x is the x squared, plus the outer terms are x and 7, so x times 7 is 7x, plus inner terms are 3 and x, so this 3 and this x, 3 times x is 3x, and finally the product of the last terms, 3 times 7 is 21. Okay, if you combine the like terms, these two like terms, you will get a 7x plus 3x as 10x. So the final form of the trinomial is x squared plus 10x plus 21. This is the product form, so the product of the two binomials. Okay, if you reverse this multiplication process, you will get in factorized form. Okay, let's reverse this multiplication process. So start with the x squared plus 10x plus 21, and we need to split the middle term 10x as 7x and 3x. Okay, x squared plus the 10x can be split as 7x and 3x. 7x and 3x. Why this 7x and 3x is? Because the product of the 7 and the product of the 7 and 3 is 21. Okay, so we need to split the middle term using this property. Okay, so plus 21. Next is grouping the first two terms and the last two terms. So x squared plus 7x grouping plus 3x plus 21. So 3x, I need to factorize this 21. Okay, so 21 is 3 times 7. Yeah, after grouping, you need to write the c as the product of these 3 and 7. Okay, next is we can factor an x from the x squared plus 7x term. Okay, terms. So x multiplied by, if you take x from x squared, the remaining term is x. If you take x from the 7x, the remaining term is 7. plus we can take a 3 from these two terms, the common factor 3 times. The remaining term is x plus the remaining term here is 7. Okay, next look at this this expression. Here the x plus 7 is a common factor. We can take out x plus 7 times the remaining term is x in the first term, and the second term it's a 3. Remaining term is 3. Okay, this is the original polynomial we started with. Okay, it's equal to x plus 3 times x plus 7. Okay, this is the original polynomial we started with. Okay, so we factored the x squared plus 10x plus 21 by reversing the multiplication process. Okay, so let's summarize these observations okay, as a guideline here. Here is the guidelines to factorize or reversing the multiplication process to factorize a trinomials of the form x squared plus bx plus c. Our idea is write the bx as rx plus sx. Here the r and s are integers whose product is c and whose sum is b. Okay, the product is the last term, the constant term c, and the sum is b. Okay, let us apply this idea to factorize a polynomial. Okay, let's start with a simple example, x squared plus 5x plus 6. Okay, to calculate the r and s, we are using a small table because we needed the factorization of the c. Okay, so we have c is equal to 6 and b is equal to 5. We need the product of two numbers whose product is 6 but whose sum is 5. So two numbers r and s whose product is 6 and whose sum is r plus s is equal to 5. So let's start with the table, a small table with the r and s. R and s, we need to factorize this 6. So and r plus s here. Okay, the first factorization, simple factorization of 6 is 1 times 6. This is r times s. What is the r plus s here? 1 plus 6 is equal to 7. But we need the 1 plus 6 as the middle term 5. So the middle coefficient 5, so it will not work. Next factorization is the 6 can be factored as 2 times 3. 2 times 3. So 2 plus 3 is equal to 5. So 5 is the middle coefficient b. So it works. We can start, okay, until you get a solution, okay. So here the value of r is equal to 2, s is equal to 3. So the resulting factors is x plus r and x plus s, but we will do systematically, okay. So let's rewrite the x squared plus 5x plus 6s using this r value, x squared plus the 5x can be split as this 2x plus 3x because of the rx and the sx. Yeah, 2x plus 3x and the last term 6. Okay, now we can group these two terms and these two terms. That's equal to x squared plus 2x plus this 3x. And we can factor the 3 as 2 times 3. This r and s, okay? 2 times 3. Okay, let's factor x from the first two terms, x from the first binomial, x multiplied by, if you take x from x squared, you will get x. If you take x from 2x, we will get 2. The remaining term is 2 plus we can factor this 3, okay, from these two terms as a common factor 3 times x plus remaining term here is 2. Now look at that. Yeah, x plus 2 can be factored because of the common factor here is x plus 2. So x plus 2 multiplied by x plus 3. This is the factorization of this trinomial x squared plus 5x plus 6 by using this method. Okay. Okay. Let us factor a slightly more complicated trinomial to get more practice again. Let me insert a page here. To do a more complicated example, slightly more complicated again. To get a better idea of this method, then we will move to the general case when n not equal to 1. Okay, let us factorize using the same method by using another trinomial. Factorize x squared plus x minus 12. Okay, so we are looking for the r and s. Okay, find r and s. Okay, whose product r dot s is equal to the c here is the negative 12, and sum is r plus s is equal to the middle term, the coefficient of the middle term, that is 1. R plus s is equal to 1 because c is equal to negative 12 and b is equal to 1. Okay, let's prepare the table, the small table. We need the combinations. Rs is equal to negative 12, r plus is equal to 1. So r plus s. So let's factorize the negative 12 first. The simple factorization is 1 times negative 12. That's equal to negative 12, and the r plus s here is negative 11. So it will not work because the middle term, the coefficient of the middle term is 1. So this combination is not working. Let's try another combination. 12 times 1, 12 times negative 1. So that's a positive 11. This is also not working. Next combination is 12 can be factored as 6 times 2. 6 times negative 2, sorry, negative 2. Yeah, the sum is negative 4, not working. And negative 2 times 6. Negative 2 times 6. That's a positive 4, not working. Okay, let's try more. 3 times negative 4. 3 times negative 4. The sum is 3 plus negative 4 is negative 1, not working. And the negative 3 times 4. Negative 3 plus 4 is equal to 1. I believe it's working. Okay, we can stop. So r is equal to negative 3. S is equal to 4. Good. Okay, let's apply the above guidelines. R is equal to negative 3. S is equal to 4. So we can write our polynomial x squared plus x minus 12 as x squared plus x minus 12 as x squared plus, we can split the middle term as negative 3x plus 4x. Yeah, negative 3x means, yeah, we can write it negative 3x. Yeah, x squared minus 3x plus 4x and minus 12. Okay, now let's group the first two terms, x squared minus 3x plus 4x minus 12. The 12 can be factorized, negative 3 times 4. So the 4x minus 3 times 4. Okay, now let's factorize x squared minus 3x by taking x outside of the first two terms. X times x minus 3 plus, you can factor 4 from these two terms. 4 times, remaining term is x here, remaining term here is negative 3. Okay, now we can factor x minus 3. So x minus 3 factored, remaining term here is x, remaining term here is plus 4. This is the factorization of x squared plus x minus 12. Okay, so next is second case. Yeah, the second case is factor trinomials with a common factor. Okay, so yeah, that is when n not equal to 1. Yeah, let me use more space here. I need to okay, yeah, this is enough to explain. Okay, for example, some trinomials looks like a 2x squared plus 10x plus 2. Okay, this is the second case. Okay, yeah, we can factor a common factor from these three terms. Here it's a 2x squared, it's a 10x, it's a 2. The common factor here is 2. So if you take 2 from each term, 2x squared becomes x squared, and the 10x becomes 5x, because the 5x times 2 is 10x. And after taking the 2, this 2 is actually 2 times 1, so plus 1. And this is the first case. When a is equal to 1, we can use the above idea to find the r and s. Okay, to make it easier to factorize, okay, by changing or factoring this 2 outside. Okay, okay, if you apply the above method, we need the product yeah, actually, yeah, better example. Okay, not 2x squared plus 10x plus 2, because this cannot be factored. Okay, we cannot find the numbers whose sum is 5 and the product is 1. Okay, let me change the example 1 second. Yeah, 2x squared plus 10x plus 8. Okay, so you can factorize the 2 from each term. 2 times x squared plus 10x can be written as 5x after factoring 2. After factoring 2, the 8 can be written as 4. Okay, now you can use the above idea to factorize the x squared plus 5x plus 4. We need the rs as 4 and the r plus s as 5. So let's start with the factoring, the table rs, and the r plus s. The first combination is factorize 1, 4. The simple factorization is 1 times 4, and 1 plus 4 is equal to 5. We are lucky enough to get the solution the first trial. Okay, so good. We can factor x squared plus 5x as 5x plus 4 as x squared plus yeah, r is equal to 1, s is equal to 4. So x plus 1x plus 4x plus 4, and we can group now x squared plus, sorry, yeah, x squared plus x plus this 4x plus 4 can be written as, so 1 times 4, that's equal to, we can factor x from the first binomial, x plus 1, plus you can factor 4 from here, 4 times x plus 1 again. Now we can factor x plus 1 times x plus 4. Okay, and now the original polynomial is 2x squared plus 10x plus 8. We already factored a 2. So the final factorization is putting a 2 in front of these two binomials. Okay, so final factorization of the trinomial 2x squared plus 10x plus 8 is equal to 2 times the x plus 1 times x plus 4. Okay. Okay, next is the general case when a not equal to 1. Okay, trinomials in the form of ax squared plus bx plus c. Okay, technically the idea is the same. Okay, only we need to rewrite this middle term as rx plus sx such that this r plus s is equal to, instead of c we need ac. Okay, this is the only change here, and this method is another name, ac plus grouping method. AC plus grouping method. AC plus a grouping method. This is another name for this method, AC plus grouping method, because we need the AC instead of C. Okay. Okay. Okay, let's start with a simple example. Yeah, we are looking for R and S combinations such that R plus S is equal to this middle term B, and RS is equal to, RS is equal to R times S. Yeah, my apologies again. R times S is equal to AC, and R plus S is equal to the middle term. Okay, let's start with a simple example to factorize this general form with integer coefficients and constant term. Okay, let's start with this, with an example. Factorize 6x squared plus 11x plus 4. Okay, so we need r plus s and r dot ss. R dot s is equal to, or the product of the two numbers is equal to AC. So that's equal to A is 6, C is 4. 6 times 4, that's equal to 24. And we need the R plus S as the middle term 11. Okay, let's factorize this 24. R dot S is equal to 24, and here the R plus S, that's equal to, we are creating a table of R plus S and R dot S. We need to equate. Okay, the first combination is the simplest factorization of 24 is 1 times 24, that's equal to 24. R plus S is 1 plus 24 is equal to 25. It will not work. Next factorization is 2 times 12, and 2 plus 12 is equal to 14. It will not work. Negative combination we will try later. Okay, if no positive combination is there. Okay. Okay, next is next factorization is 3 times 8, and what is 3 plus 8? That's equal to 11. Yeah, what is middle coefficient? Yeah, that's correct, 11. It works. Okay, it works. So we can rewrite the original polynomial. The original polynomial is 6x squared plus 11x plus 4. 6x squared plus 11x plus 4 as, by splitting the middle term 11x as 3x plus 8x, because r is equal to 3, s is equal to 8. So this can be realized 6x squared plus 3x plus 8x plus 4. And grouping, okay, grouping the 6x squared plus 3x, 6x squared plus 3x plus the 8x plus 4, 8x plus 4. Okay, let's take the common factors. The common factor of 6x squared and 3x is, we can take a 3 from the 6x squared, 3 and the x from the 6x squared, and a 3x. So if you take 3x, the remaining terms are, if you take 3 from 6, the remaining is 2, because 2 times 3 is 6. If you take x from x squared, you will get x. If you take the entire 3x from 3x, the remaining term is 1, because 1 times 3x is 3x. Plus, if you can take a 4 outside, okay, outside from these two terms. If you take a 4 from the 8x, you will get 2x, because 2x multiplied by 4 is 8x. If you take 4 from 4, you will get a 1. The remaining term is 1. Okay, now the common factor here is the 2x plus 1. Again, you can take outside. So that's equal to 2x plus 1 multiplied by, the remaining term here is 3x plus 4. Okay, this is the factorization of this trinomial, 6x squared plus 11x plus 4. Okay, next is an example. The example here is a special example. Next example. Example is factorize negative 4h squared plus 11h plus 3. Here the variable is h. Look at that. The coefficient in front of the first term, or the a here, is a negative term. So it is worth mentioning that we can factor that -1 inside of the -4 outside it to make it easier to factorize. So if you take a -1 from outside, from inside, it becomes a -1 times 4h squared minus 11h minus 3, reversing all the terms. Okay, if you take -1, now it becomes a standard form, 4h squared minus 11h plus 3. Here the a is positive. We can apply the rule we learned from the above two examples. Okay, now here a is equal to 4, b is equal to -1, and c is equal to -3. And we will adjust the -1 later, okay? So let's factorize the 4h squared minus 11h minus 3. Okay, here the AC is equal to 4 times -3, that's equal to -12. And the B is -11. Okay, so that means R times S is equal to -12, and R plus S is equal to -11. Okay, let's factorize, or let us prepare a table of R plus S and R times S, R plus S and R times S. Yeah, the first combination is, or the first factorized form of -12 is -1 times 12. And if you sum, you will get positive 12, okay? Yeah, so plus -1 is positive 12, positive 11. And to switch the other way, 1 times -12. that's equal to -12, and the sum is -11. We are success, okay, to in finding a solution, okay, to this equation, okay. So our value of R is 1, S is equal to -12, and R plus S is -11, R times S is -12, okay. So 4h squared minus 11h minus 4, sorry, minus 3, yeah, that can be written as 4h squared. We can split the middle term as plus 1h minus 12h minus 3. Okay, now group the first two terms and the last two terms. That's equal to 4h squared plus h minus, if you take minus from the two terms, you will get a 12h plus 3. If you take minus outside, okay, 12h plus 3, 12h plus 3, if you take minus from the two terms. Okay, now we can factor h from the first two terms. So h times 4h plus 1 minus, we can factor 3 from the last term and the first term 12. If you take it 3 from the 12, the remaining is 4, then 4h. If you take 3 from 3, you will get a 1. Again, yeah, here is a common factor, 4h plus 1. That's equal to 4h plus 1 multiplied by h minus 3. Okay, this is the factorization of 4h squared minus 11h minus 3. We need the factorization of negative 4h squared plus 11h plus 3. That's equal to negative 1 times 4h squared minus 11h minus 3. That's equal to negative 1 times 4h plus 1 times h minus 3. Okay, we are done. Okay, now before winding up today, let me mention that not all trinomials with the integer coefficients and constant term, it can be factored like this, okay? For example, 2x squared plus 35x plus 7, okay? Yeah, this polynomial, this trinomial cannot be factored like the above style, because there is no combinations of numbers whose product is r times s is equal to 2 times 7 is 14, and r plus s is equal to 35. Okay, let's look at that. Okay, so here the r times s and r plus s. First is how do we factorize this 14? 14 can be written as 1 times 14. That's equal to 14, and the r plus s is 15. And next combination is, it's a negative equivalence, but we are not checking with that because we need the sum 35 positive number, so ignore that. Or if you write the negative 1 times negative 14, and you will get a 14, but its a sum is negative 15. The other combination is 2 times 7, its sum is 9. If you take the reverse of these numbers, negative of these numbers, you will get a negative 9. And the other factorization is, I think there is no other factorization. Yeah, these are the only possible factorizations. Okay, there is no combinations of R and S whose product is negative 14, 14, and the sum is 35. So this trinomials with integer coefficients is not working. Okay, thank you. Yeah.